Hello everybody, it's Friday the 12th of February, it's the last maths lesson until the holidays, yippoo! And we are looking today at adding and subtracting fractions. So for this you will need paper and pencils. You might want to draw out your fraction bars to help you. And let's get started with our 4 a day. Pause the video and have a go at your 4 a day and then your answers will come after. Here are your answers for your 4 a day. Have a look and see how you did. If you made any mistakes, can you work out where your mistake was? We're going to begin with our get ready questions. Again, want you to pause the video, have a go at the questions and your answers will follow. Let's have a look at the answers. So question 1, we had 5 apples, add 2 apples is 7 apples. So if we did the same question, but with fractions this time, if we had 5 thirds and 2 thirds, we would have 7 thirds. Then question 3, we had 7 ninths, take away 4 ninths. So we can see we have a fraction bar of ninths with 7 of those ninths shaded. We're going to cross out 4 of those ninths. How many are left? 3 ninths. Then we had question 4. We had 8 elevenths. Take away 5 elevenths. Take away 1 11th. And the same, we have the fraction bar split into elevenths. 8 of those are shaded, so 8 elevenths. We take away our 5 elevenths. Then the 1 11th. And that leaves us with 2 elevenths. So now we're going to get ready with the main part of our lesson, and it's going to involve adding and subtracting fractions. Let's begin with this question here, and we'll work on this one together. Dexter eats 2/5 of his chocolate bar. Alex eats 4/5 of her chocolate bar. Do they eat more than one whole chocolate bar all together? I'm going to give you 10 seconds to have a think what your initial answer would be. What can you see about those fractions that might tell you whether or not they've eaten a whole bar altogether? Let's have a look and see together. So we can see that there is Dexter's chocolate bar of 2/5. There is Alex's chocolate bar of 4/5 eaten. So we're looking at doing 2/5 add 4/5. And the answer is 6/5. And we can see if we move one of those sections, fifths, over to the 4/5, we've now got 5/5. One whole has been covered. So the answer is 6/5 is the same as 1 whole and 1/5. Then we go back to the question, do they eat more than one whole chocolate bar altogether? And the answer is yes. So looking at that skill we just did, can you answer this question? What is 3/7 add 6/7? Use the fraction bars if you need to. Can you answer your question as an improper fraction and a mixed number? Pause the video and have a go. Let's have a look and see. The answer should be 9/7, which is equal to 1 whole and 2/7. Well done if you managed to do that one. Now we can look at it in another way. We can look at it as our part-whole model. So we have 9/7 at the top, and we can then split that part model into 2, and we can use our 7/7 from our 9/7 and our 2/7. And 7/7 is the same as 1 whole, leaving us with our 1 whole and 2/7 for our mixed number. So there's another way that we could use a part-whole model to help us. Let's have a look at this one now. We have 3/8 add 3/8 add 7/8. So we've got 3 fractions to add there. First of all, we should have done use our number bonds to help us. 7 add 3 is 10. 10 add 3 is 13. So altogether we have 13 eighths. And if we use our part whole model, we've got 13 eighths. What would go here? How many eighths would we put? We would want it to be 1 whole. And that would be 8 eighths out of the 13 eighths go here, which means what would go in this other part whole model? It would be 5 eighths. Then our 8 eighths can turn into our 1 whole, and that's a way we can get our mixed number. So their answer should have been 13 eighths is equal to 1 whole and 5 eighths. This time I want you to pause the video, have a go yourself. How would you answer this question? Adding those 3 fractions together, and if you need to, can you use your part whole model to help you turn your improper fraction into a mixed number? Pause the video and have a go. Let's have a look and see. Well, if we did 8 elevenths, add 10 elevenths, add 6 elevenths is 24 elevenths. Then we could have got our 24 elevenths and we would have had to have split it into our whole numbers and our fraction. And knowing our 11 times table, we could have got 11 elevenths, which is 1 whole, another 11 elevenths, which is another whole, leaving us with, that's 22 elevenths we've used so far, leaving us with 2 elevenths left out of the 24, giving us our answer of 2 wholes and 2 elevenths. Well done if you managed to do that one. Now we've done adding, let's have a look at subtracting. We've now got 11 eighths, take away 2 eighths. Here are our 8 eighths and 3 more eighths, giving us our total of, there is our 11 eighths. We're going to take away out of those 11 eighths, going to take 2 of them away. What have we been left with? Hopefully you worked out the answer is 9 eighths. That's our answer as an improper fraction. What would it be as a mixed number? The answer would be 1 whole, which is this first fraction bar because the whole thing is shaded, and leaving us 1/8 in the other fraction bar. Now you have a turn. What is 7 quarters? Take away 1 quarter. Can you write your answer as an improper fraction and a mixed number? Pause the video and have a go. Let's have a look and see how we did. Here we've got our 7 quarters. Here we've got 4 quarters and 3 quarters. Together we take away that 1 quarter, which leaves us with 6 quarters. And as our mixed number, we can use our part whole model to help us. 6 quarters we can split into our whole, 4 quarters, and leaving us with 2 quarters left over, which is 1 whole and a half. We could have changed it and kept it at 2 quarters, but we could have also changed it into its simplest form of 1/2. Well done if you managed to do that one. Again, this time, pausing the video, how would you answer this one? If you need to draw your fraction bars to help you, you can do. If you want to use your part whole model to turn your improper fraction into your mixed number, then you can do that too. Pause the video and have a go. Let's have a look and see. So we had 21 fifths, take away 2 fifths, take away 3 fifths. So first we should have done 21 fifths, take away 2 fifths, and that would have left us with 19 fifths. Then 19 fifths, take away 3 fifths, would be 16 fifths. That's our answer as an improper fraction. What would it be as a mixed number? Out of our 5 times table, we know 5, 10, 15 fifths is 3 wholes, and it would have been 3 wholes and 1 fifths. Now that we've looked at those skills, you need to now have a go at some questions by yourself. Go back through the video to help you see how we did it. Draw your fraction bars, use your part-whole models to help you. Pause the videos and then afterwards your answer will follow. Have a go at these questions. Complete the calculations. Use the bar models to help you. So draw them if you need to, or if you've printed out the sheet, you can colour them in. Here are your answers for those 4 questions. Have a look and see how you did. Next question, can you complete the calculations? There are 10 for you to try. Pause the video and have a go, and your answers will come after. Here are your answers. Mark them and see how you did. If you made any mistakes, can you work out where that mistake was? And then we're going to look at the next part. Let's have a look at this question now. You've got missing numerators. What could they be? It would be something eighths. Add something eighths equals 13 eighths. And it asks you, can you give 6 different possibilities? Pause the video and have a think. What could those 6 possibilities be? Here are your answers. And we can see that they are in an organized way. So mathematicians would think, how can I do this in an organized way? And we can also see there are only 6 possibilities. We could have had, for example, 9 eighths, add 4 eighths, but that was still using the same 2 digits. So it doesn't matter that you haven't got the digits the right way round. You might have 9 eighths, add 4 eighths, but as long as you've got those correct digits, then that will give you the right answer. We're going to move it on a little bit now and have a look a little bit more at how we could answer these questions. So again, we have a missing numerator for our fifths, and it says something fifths, take away 7 fifths, take away 8 fifths, equals 4 wholes. Have a little think for 10 seconds. What do you think you need to know about this question? What might you think number do you think would be here? Would it be smaller than 7 and 8? Would it be larger? Would it be much larger? What about this 4 wholes? This is a mixed number. This is a regular proper number. What would it be if it was an improper fraction? Is there any way that you can think you could change something to help you? 10 seconds to have a think. Let's have a look and see. Well, we know that 1 whole equals 5 fifths. 2 wholes equals 10 fifths. 3 wholes equals 15 fifths. So what would 4 wholes be? It would be 20 fifths. So now we know our answer is the same as 20 fifths. So something fifths, take away 7 fifths, take away 8 fifths equals 20 fifths. What could that missing number now be? What would you do to find that missing number? I'll give you 10 seconds to have a think. Let's have a look and see. Well, we should have done our 20 fifths, add our 8 fifths to give us 28 fifths, and then 28 fifths, add our 7 fifths to give us 35 fifths. Our answer was 35 fifths. This time, let's have a look at this problem. We've got 5 halves, add a half. What does that mean if this equal sign is in the middle? It means it is equal to. So our answer on this side must be the same as our answer on this side. What could it be? The difficulty here is we look at denominators are not the same. This might make a difference for us. Let's have a look and see what we would do. Well, we know that we can do this side, 5 halves, add 1 half equals 6 halves. And we know that 6 halves is the same as 3 wholes, 2, 4, 6. So we know that our answer on the left equals 3. That must mean our answer on this side must equal 3 as well. So if we already have 14 ninths, how many more ninths would we need to make 3 wholes? What do you know about your 9 times table to get you 3 wholes? Going to give you 10 seconds to have a think. What could you do? Let's have a look and see. 3 wholes is 27 ninths. Now if you already have 14 ninths of those 27, how many more would we need to get 27 ninths? And the answer would be 13. And that's a way that we can find out our missing number there. Looking at those 2 skills, pause the video and have a go at these 2 questions. What are the missing numerators? Let's have a look. The first one, we had 4 wholes, which is the same as 24 sixths. So 29 sixths, take away something equals 24 sixths. The answer would be 5 sixths. Then we had a missing numerator. Something tenths, add 17 tenths is the same as 17 thirds, take away 2 thirds. Well, we know that 15 thirds is equal to 5 wholes. So 5 wholes would be 50 tenths. So if we take that 17 away from 50, our answer would be 33 tenths. Well done if you managed to do those ones. Now we've got a word problem here. Mo and Tommy each have a jug of milk. Mo's jug contains 5/7 litres less milk than Tommy's. The total milk in the 2 jugs is 3 wholes and 2/7 litres. How much milk does Mo have? So let's have a look at the question again. So Mo and Tommy each have a jug of milk. What do we know about Mo's jug? His contains 5/7 of a litres less milk than Tommy. So Mo, we know, has less milk than Tommy. Together, the total milk in the 2 jugs is 3 whole litres and 2/7. How much milk does Mo have? Now to solve this, we're going to use a bar model. Here is how much Mo has, and here is how much Tommy has. We know that Tommy has more than Mo, and we know the total milk in the 2 jugs when added together gives us a total of 3 wholes and 2/7. And we know that Mo has 5/7 less than Tommy, which is shown here. If this is Mo's, we know that this part of Tommy's would also be 5/7. If we took 5/7 away, what would we have? We would have 23/7, take away 5/7 equals 18/7. So between us, we now know that there is 18/7 between Mo and Tommy's. So if Mo has 18/7 and Tommy has 18/7 combined, their total is, what would one amount be? And what would be in Tommy's? The answer would be 9/7 in Mo's and 9/7 in Tommy's. So we've got 9/7, add 9/7 is 18/7, plus the 5/7 more that Tommy had than Mo, which is 23/7, which is the same as 3 wholes and 2 sevenths. So to answer the question, how much milk does Mo have? The answer is 9/7, which is also the same as 1 litre and 2 sevenths. Coming up now are some questions for you to try, using the skills we just looked at to help you solve them. Can you fill in the missing numerators? Look carefully at the questions, have a go, and your answers will come after. Here are your answers. Can you mark them to see how you've done? Here is another question for you to try. Here are some fraction cards, and there are 6 there. Use the cards to write pairs of fractions with a total of 2. So you can only use one fraction card once. So you couldn't use 9/8 here and 9/8 here. You can only use each card once. Use the cards to write pairs of fractions with a total of 2. Pause the video and have a go. Here are your answers. Have a look and see how you did. Well done if you managed to get those. Let's have a look at some other questions. Here is a problem. Annie and Dexter both have a skipping rope. Annie's rope is 3/4 of a metre shorter than Dexter's rope. The ropes are 13/4 metres altogether. How long is each skipping rope? So this is using the bar model like we did with the previous question. What you need to do is try and draw your models. If you want to, go back and look at how we did it before and see if you can use that to help you, and your answer will follow. Here was your answer. Annie's rope is 1 whole and 1/4 metres long. Dexter's rope is 2 metres long. Well done if you managed to do those. That was a tricky one. Here's our last question and challenge for you to try. It's called Pick a Pair. You've got 4, 8, 12 fractions there and 2 challenges to try. The first one says, find pairs of numbers that give an answer of 1 whole and 3/8. And we know that that is also 11/8. So we can see here this one would be correct because 6/8 add 5/8 is 11/8, which is the same as 1 whole and 3/8. Whereas this one would not work because it says 14/8 take away 1/8 is 13/8. And we know that that would not work because 13/8 is not the same as 1 whole and 3/8. And the other challenge for you to try is, can you find pairs of numbers that give a difference of 5/8? So here are 2 examples. I'm going to see if you can work out, are they correct or not? And if you think they are correct, you can see how it's done. And then your challenge is to see if you can find any other pairs. Can you find pairs of numbers, fractions that give an answer of 1 whole and 3/8? It could be addition or subtraction. And can you find pairs of numbers that give a difference of 5/8? So there's your final challenge for today and your final maths lesson for the holidays. So it's goodbye from me, and I'll see you in a week or 2. Ta-ta!